Check the video out now, man. Like, comment, subscribe.
I'm currently working in an offline mode on the Motec and continually consolidating the software to match my physical hardware for the Audi TT 3.6 liter engine. I need to disable the Bank 2 camshaft output resources, and what this will do is reduce any type of invalid errors that I currently have on the computer, as well as free up any extra pin output resources that I can use for other important sensors. In order to accomplish this task, I need to go to two of my worksheet pages. Currently, I'm on the camshaft control inlet page, and then I need to go to two of the resources. The important resources that I need to disable are the camshaft inlet bank 2 position resource and the inlet camshaft bank 2 actuator resource. I need to do this for both pages, for the inlet as well as the exhaust camshaft. Or just to clarify a little better, Bank 1, I don't want to mess with that because specifically for this package for Teddy's engine, Bank 1, we want to leave that set up as our default source and eliminate Bank 2. So in Motec's architecture, Bank 1 is always the primary default bank for any single cylinder head configuration or inline staggered setups like our VR6 engine. The ECU relies on Bank 1 for the core engine speed synchronization, rev sync, and primary variable cam control logic. Therefore, Bank 1, we want to leave that alone, even though I still have solid or got rid of our variable intake and exhaust camshaft actuators for an adjustable fixed sprocket that we can pretty much adjust and fix at a certain position. And maybe we will go to the variable inlet and exhaust at a future time, but for the time being, we want to still stick with that. I'll keep these resources open for future use. I may still disable them. I'm not going to utilize those inputs, but we want to still have those options available for future setup. But either way, let's go ahead and enter these parameters. I'll type in pretty much inlet camshaft bank 2 position resource and see if we can find that, and we'll disable it from this global search. Well, on the exhaust side, it appears that I may have already disabled my exhaust camshaft position on bank 1 and bank 2, possibly from a previous session, maybe when I was setting up the camshafts and or merging the packages with the R8, and you can see all of these other sensor resources all the way up to cylinder 12 is not in use. So it's a possibility I may have already disabled this from a previous session, but nevertheless, it's disabled, which was the main objective that I wanted to accomplish. But something else that appears up in here, for example, exhaust lambda bank 2 is disabled as well. We may go back and enable for the lambda setup for our exhaust system, which I'm pretty much going to enable, whether I set it up for a bank 1, bank 2 configuration, or just set it up separately. And for example, cylinders 1, 3, and 5 is originally for bank 1 on our VR6 engines, and 2, 4, 6 is bank 2. I may still utilize that configuration or just set it up for cylinder 1, which would be for bank 1, and put an exhaust probe in bank 2, cylinder 2. And that way, when I do individual cylinder tuning, I can pretty much measure out the banks that way. For example, as I stated, 1, 3, and 5, I would bounce the probe from that set of bank from my dual sensor, and then use the second sensor and bounce that around from cylinders 2, 4, and 6 as far as tuning, which means this dual lambda LTCD sensor, we can utilize that for monitoring 2 sensor setups. And basically, either way, whether I utilize it, like I said, for bank 1 and bank 2, or just cylinder 1 and cylinder 2, I'll bounce those exhaust O2 sensors around in those cylinders just to get this tuning a little more closer and accurate like I would want to for Teddy's engine setup. And if I type in bank 2 exhaust, you can clearly see that these sensor resources are already disabled and not in use, which is good. I want to basically say that the original GM package would have those enabled. That utilizes a quad cam and utilizes VVT on all camshafts, the intake and the exhaust camshaft profiles. Therefore, is a possibility, or definitely, I somehow disabled these when I merged it with the Audi R8 package and started disabling a lot of the functions, or somehow it just became disabled doing that merge. But more likely, I was just going through and disabled during the previous session, which is good to know. So that's good. That's cleared up. It was originally enabled with the GM package. Now we're slightly getting this engine configuration a lot more custom tailored to a VR6 direct injected package, which is a great thing. I've entered my camshaft profiles, which is very, very great. We actually monitored the camshaft through a complete combustion cycle. And what I did was measure out the direct injection pump lift per every stroke as far as the base circle. So throughout that combustion cycle, we actuate the pump 3 times during a combustion cycle, and I measured that profile for lift as well as base circle throughout each step on a degree wheel, and that worked out great. So of course you probably already saw the video with just a couple screenshots and how I set up the dial indicator for the cam lobe itself, and also the degree wheel on the crankshaft. But while setting up my field pressure direct aim table, I came across some great information. A target of roughly 725 to 870 psi, roughly 50 to 60 bar, is the industry gold standard for starting and idling a medium displacement direct injected engine. At this pressure, the factory direct injection system has enough hydraulic energy to cleanly atomize the fuel through the nozzles for a crisp, stable idle. However, it doesn't push the high pressure fuel pump so hard that it builds excessive heat or causes unstable pressure oscillations while the engine is still cold. Now, there is a problem with my current setup. This lower section that I have highlighted right here, that looks relatively good for the most part. But as we step up to the upper section here, there is an issue. My current setup was previously listed in megapascals, and I changed it from that to PSI, something that I'm a little more familiar with and that I like to stay consistent across the board with setting my boost pressure, any type of field pressure, and everything consistently to PSI, so that way I don't have to bounce back and forth. On my table, we have the engine RPMs listed. We have fill volume per cycle, which is in microliters, and this part of my table is for PSI. That is to pretty much target my rail pressure. The issue is up here where I have this 1740, that is pretty much the maximum pressure that I want to even have on my table, because my relief valve and my fill pressure rail bleeds off roughly right around that 1740, 1735 psi. We do not want to be anywhere close to that limit, so these values will need to be dropped down drastically. If I'm not mistaken, when I merged this pretty much with the Audi R8 configuration, these may have been the higher up limits, but my engine is not going to see any fill pressures that high, at least not at the current stage. So we need to definitely drop those numbers down. I'm going to revamp this table so that way it's a little more consistent for our setup, for our Audi TT 3.6 liter turbocharged setup. And that way we'll be in a safety range and we can eliminate these conflicts with this current table.